Hello. Today we started thinking about how we can generalize, which is to say how you can set up an expression or a rule that you can use no matter how big or how small the numbers that you're looking at are. Starting with our practice check, we had 2 tablespoons of sugar needed to make 10 cookies, and I wanted to know how many tablespoons you would need if you wanted to make 35 cookies. So this comes straight out, kind of the same kind of reasoning that you were using on Friday in class. It helps to set yourself up some kind of table. So if you know that 10 cookies is going to take 8 tablespoons of sugar, collect that information for yourself. Well, to get up to 35 cookies, you would need to multiply by 3.5 because 10 times 3.5 is 35 cookies. So we've scaled now. We've scaled it up by 3.5. When we scale that recipe up by 3.5, that means we're going to need 8 times 3.5 or 28 tablespoons of sugar. Here now we revisited a situation from last Tuesday, looking at some ingredients that would be required and things you'd be able to make for people with those ingredients. So I have the table set up already for you. We know that it's a proportional relationship between the cups of Bisquick required to serve people waffles and the amount of oranges needed to serve people orange juice. But you'll notice in the last line of each, I'm now asking you for any number of cups of Bisquick or for any number of oranges. So I'm going to show you what 7A has for this. They set themselves up their tables, and then when they got down to X cups of Bisquick, most groups decided to start just making a number up. So I had some groups that were like, well, I had a group that said 16 cups of Bisquick. Let X be 16. Another group said, let X be 6. And I ended up pushing them, what if X was something like 1/8? They said, well, no matter what, we need to multiply by 3 because we see that the rule, looking up at 2 cups of Bisquick, 2 times 3 is going to feed 6 people. So if our rule is times 3, we could write it in several different ways. One, in English, you could just say the number of people you can serve is going to be X times 3. If you wanted to put that in more mathematical language, you would say 3 times sine X, or even just 3X. That means the same thing as 3 times X. I then asked what was an equation we could write for that. And if we said number of people is equal to something, number of people could be equal to 3 times X, and X would be that variable for the number of cups of Bisquick that you've got. In that, Michaela was asking about where does the constant of proportionality come in here? She noticed that times 3 is the constant of proportionality, 3 is in the rule. We also seem to see 3 in the equation. So she pointed out that 3 is in there somewhere, and we noticed that throughout the equations that we ended up working with, that ended up being involved with what you were multiplying or dividing your variable by. So it shows up in the equation. Here it's that 3 in front of the X for 3 times X. So then looking down at the oranges situation, we had several different equations people ended up generating. One was that the number of people you could serve was R times 1/2, because 6 times 1/2 is 3. A second is that it's R divided by 2. And we noticed that the relationship between R times 1/2 and R divided by 2 is that 1/2 and 2 are reciprocals. And then if you take R times 1/2 and turn it into a decimal and switch the order, which does not matter when you're multiplying, you could also have the number of people could be 0.5 times R. And those were 3 equations that we ended up agreeing all worked for this table. And as you see circled in the dark red, we see the constant of proportionality, particularly that half, but also if you were to look back across the table, the constant proportionality to get from the number of people to oranges would be 2, and we see that there in that R divided by 2 as well. I only looked at this problem with the first class, but I said that I would bring it up in my video for people who wanted to see some more examples. So here what's tricky is that there is not an obvious multiplier. 1.5 hours times, it's not clear what you need to multiply that by to get 915 miles. You don't yet have your speed in miles per hour because it takes 1.5 hours to travel 915 miles. So I encourage students to look at how far could you go in 1 hour. If this is proportional and you know that you need 1.5 hours to travel 915 miles, how could you get back to 610? Excuse me, back to 610. The way that you could do this is if you were to scale back. So 1.5 divided by 1.5 would get me to 1 hour. And that means that I also then need to divide 915 miles by 1.5, which gets me 610 miles per hour. Now I have a speed of 610 miles per hour. Every hour I'm going to travel 610 miles. This is a constant speed problem. So that means that every single amount of time is going to take 610 miles per hour, or it's going to be at that speed of 610 miles per hour. So if we're going from 1 to 610, that's times 610. So I can do 2 times 610, which is 1,220 miles. I double my time, I'm going to double my distance. 2.5, if I do 610, and then generally, if I go t hours, and I'm traveling at the constant speed of 610 miles per hour, I would do t times 610 to figure out how far I've gone. An equation then that I could write if I were using just replacing d for distance would be d equals 610t, because that is telling me every amount of time times 610 will give me the distance that I'm going to travel. So then this is where it becomes really useful. If you have 3 hours at that speed, you don't need to play with the table anymore. You can just use your equation. 610 times 3 hours is going to give me 1,830 miles. And it's great when you have decimals too, because now you know you can just put those decimals in. You don't really need to think about fractions of an hour or parts of an hour. 610 times 3.5 and get my mileage that I'm going to travel. As you are looking at your homework tonight, an important thing to notice is that we already have a unit rate provided. Every square meter of ceiling requires 10.75 tiles. I can fill that information in right away, because if I have 1 square meter of ceiling, that means it's going to take 10.75 tiles. And I should be able to use that information to create a constant of proportionality that I could use to then work my way from 10 square meters to the number of tiles, work backwards from 100 tiles to the number of square meters, and generalize. If I have any number, A, square meters of ceiling, what would I need to do to get the number of tiles?